yeah, there is around 40 years of experience in this area, and I showed in the beginning the presentation with the maturity model about estimation maturity, what comes from the book from Dan Galorath, what I have here in my study room available. We talked about it when we had a tryout session, that it was that the book's already 10 years old, but still relevant. And it's great because Dennis, he founded Galorath with a vision, and he grew that over the times, has a lot of experience, and he will talk about software sizing from his perspective. So good to have you here, Dan. So if you are ready, then I'd say please go ahead.
Thank you very much, Eric. You all seeing my screen?
Yes, I can see it clearly, Dan. Thanks.
Okay. Again, as Eric said, I've been doing this a long time, and we've evolved in many ways in how we calculate software size, but some things remain sort of the same. We started out with memory words. If you had I'll show you an example in a minute. If you had a machine that would have 64K bytes, we would figure out how many memory words that was and could use that as a size because you couldn't put any more in than that. Then it went to assembly lines of code. Then assembly lines of code derived from source. I'll show you a few examples of these. To source lines of code, to effective size, which I've heard referred to a couple of times here, to something we call COTS Cognition for commercial off-the-shelf. Functional sizes, and I think everybody here knows a lot about functional sizes. Relative sizing, well, I'm getting dizzy just saying this. An effective functional size. I'm going to go through some of these. First, historical sizing. We did this for people like the US Air Force and others. You have a 64K byte system. You must have a 20% reserve for growth. That means there's 52K bytes of code used. Bytes per instruction, per computer instruction, depending on the machine, generally like 6 bytes per instruction. That was about 8,700 lines of code. Life was easy. Obviously, there's more complexity to this, but when you look, by the way, at Internet of Things today, but 40 years later, this might not be a bad way to estimate the size of the code in Internet of Things. As you know, you've got fixed size, and you might want to convert it to a high-level language, but this is still potentially relevant today. I learned the C language, C programming language, shortly after it was developed. And one of the beauties I loved, I was a software developer at the time, you could look at the code, the C code, and you could tell what the assembly code was going to be. So source to object and object to source, here we can see a little bit of C code on the left. And on the right, we can actually see the original instructions. This is PDP-11 assembly language that would have been generated. So you could take the high-level language and you could estimate the number of words, computer words that would be used. I'm not sure that's as useful today. Now this is the Galorath multi-method size study approach. We've used this for years. We don't use it as much anymore with functional sizes, but some. And the way it worked is we built a table. Here you can see a table. The top one says expert judgment, and the left-hand column is least, middle one's likely, right one's most. So we get the expert judgment, and this example here is lines of code. How many lines do you think this would be? Least likely and most. Now there's a whole trick to asking people about estimating lines of code I'll talk about in a minute. Then we did relevant range by analogy, analogous programs. And again, best case, likely case, worst case. Then sizing database. I love hearing so many people talking about sizing databases today because I believe they're critical. And a functional analysis converted perhaps. Seer estimate by comparison, which is a relative size. Some of you may be familiar with it. It also uses similar approaches to what Tom Soddy did, AHP. Anyway, however many ways we could size, we would put in a table like this: best case, likely case, worst case. Then for the composite, we would generally have a rule that said you drop the lowest of the low because software never gets smaller, and we take the low. For the high, we take the highest of the high, and for likely, it depended on the range, but oftentimes it would be the average. So here, we have used this on many years ago on numerous programs where it got through the scrutiny of the Air Force and the Office of Secretary of Defense and the organizations like MITRE. This has still got some relevance today. Again, if we had a manual function point count, we might put the manual function point count in this table. If we had one from a quick sizing method, we might put that in the table. If we then went into a sizing database, we might put that in the table. So when we went to people to brief the size, we had credibility by having the size backed up in a viable range. Carol talked about effective size. I was thrilled to hear that. The reason that effective size is useful is it takes something, for example, if you have something that's 1,000 function points and you add 2, well, how much work is that? Effective size defines how much work in terms of redesign, reimplementation, and retest. And very powerful method for lines, for function points, for anything that you're doing is to compute the effective, not the total. For example, if you started out with 1,000 and you added 2, the total's 1,002. The effective might be, depends on how much redesign, reimplementation, retest, might be 10 or 20 or something like that. Here we can see, this is an eye chart, I apologize. Here's a table for figuring out how much rework. For example, if you are retesting something and it was pre-existing, you got to retest it all again. That's a substantial amount of work. If we just look at the basics, we might miss all the work of retesting. Same with re-implementing and redesigning. So we have found that this is a keystone. I've written this a million times. I think it was in one of the IFPUG books. It's certainly all over. It's in our books. It's on our website. But the methods of coming up with effective size can be very powerful, independent of whether you're using lines or functions or something else. Now, I'm thrilled to hear. I thought I was going to come to a group of people that said lines of code. I'm going to just go take a break now. We love function points. We love lines of code when appropriate. We use whatever makes sense. And again, we're size agnostic. Here we see some lines of code on the left. Now here's one of the problems. If you ask a programmer how many lines of code this is, well, they'll probably they'll think of lines of code as number of carriage returns, and there's 15 carriage returns. If you use the standards, I hear people say there's no standards for counting lines of code. I hear that all the time. Oh, functions have got standards, lines of code don't. There are standards for counting lines of code. They're used by us and by University of Southern California and probably every other software estimating vendor, and they're fairly simple. On the right, you can see all the details. You know, you count examples of counting different kinds of statements and what they do and what they don't include. For example, on this thing on the left, the first line we see procedure example. The next line's a blank. Well, how much work is there involved in doing a blank line? Like 0. The next line is a line of code. You can see it's got some context to it. But notice most modern languages today have a line terminating semicolon at the end of a line. So counting lines of code is by an automated method is almost trivial in most languages today. We just count the number of line terminating semicolons pretty much. And knowing that rule, now again, if you talk to a programmer, say how many lines of code is it, and they say, well, 15, and you ask them how many line terminating semicolons, they won't know what to do. But this is very valuable for automated sizing, for automated counting. Carol referred to the SRDR database, thousands or hundreds at least of major programs with the size carefully counted. So yeah, lines of code, have they got a standard? Absolutely. Is it an ISO standard? No. Is it worth getting an ISO standard? Probably not. But when using standards, you've got something you can depend on with lines of code. I know all the arguments against it, and I'm not suggesting it's the only way. If this was generated code, it doesn't work as well. But lines of code has some value. I'll show you that even today. And once again, if you're doing Internet of Things, lines of code may be completely appropriate. Commercial off-the-shelf software packages. Estimating packages. If you look at packages, the blue shows that there's some stuff we're building. Then the green shows the commercial off-the-shelf or package code. And the white is the glue in between, the stuff that ties them together. For example, if we were building a program and we were using a graphics generating database, we would have the developmental code, and some of the code might be calling or or instantiating somehow the graphics database software. There might be some glue code to tie them together, and then the actual commercial off the shelf. Even today, this can be very valuable to know how much work, and this works functionally as well, of course, how much effort is going to be involved in adding or redeveloping a system that's mostly commercial off the shelf. Now, we've come up with something called COTS Cognition. COTS is commercial off the shelf software, and I'm not going to go through the details, but if you're using a package, you know, how much work is it? It's kind of it's irrelevant how many lines of code it is generally. It might probably irrelevant how many function points or whatever you're using generally, but there are some things that are key. How many features are involved that you're going to use? One of the big companies in aerospace companies in the U.S. use our COTS Cognition and went through and found they could take the table of contents for a package and use that as an input and get an estimate. And in their studies, it was like within 2%. I'm not sure I recommend that for everybody, but looking at what kind of objects, what kind of high-level descriptions of the functionality, and then figuring out how much of it's got to be learned or used and tested. Here's one of fascinating use of lines of code. There used to be two of these databases. I think one of them has gone away, but this particular organization, Coverity, scans and counts the lines of code of open source software. They then can give you quality definitions. Now, suppose you're going to use open source software, and which most people are using for something today. That's great, but how much is the effort involved in using it? COTS Cognition or this? How much work is there and risk is there in reliability? How many bugs are there in the software that are going to cause you problems? Well, that's an interesting story. I know if I go back in history a number of years ago, a lot of years ago, when Byte magazine was still published, we Galorath had done an estimate of Microsoft Word for something. I don't even remember why, but when we were all done, in fact, it might have been for that magazine that asked us to do it. We came up with an estimate of something like 5,000 defects, delivered defects in Microsoft Word. Microsoft had a heart attack. They said, "Don't publish that. Don't publish that." So that number of defects that were estimated by looking at the size of the code and lines of code was eliminated from the article. But then I forget, about 18 months later, Microsoft came out with a statement that said they had about 5,000 defects in Word. We were able to estimate the number of defects in the delivered system based on the lines of code that were involved. There's lots of techniques to do that, and this isn't the main topic of this presentation, but there's value to these lines of code for that as well. So again, let's suppose you're using a graphics program, and that graphics program is open source, or it's you might be able to go into this database, find out how many lines of code it was by an automated code counter using a standard, and then figure out how much of that you're going to have to test. And you can use things like seer or effective size or other things to do that, and actually have a better estimate of what that open source is really going to take in terms of effort and effective size. Comparative sizing. I love comparative sizing. Now, comparative sizing, of course, assumes you have a database. And studies were done many years ago. Again, Tom Soddy with his AHP, analytical hierarchy procedure, did some of the first ones. We did a number of studies with them, working with other people as well. And here's what we found. People can estimate things relatively much better than they can from scratch. Now, for example, if we were looking out at a building from our office, by the way, we haven't been in our office for 8 months, but if we were in our office and looking out, we could see the building across the street. And if I told you that building was 200 feet high, you could then look at another building that was nearby and say, how much is that? And they say, well, it's a little higher, a little smaller, and come up with a really good estimate of relative size. Well, the same thing works for software. So if you have a database of software, whether it's lines of code, whether it's functional, whatever it is, and you have people estimate relatively, is this bigger, a lot bigger, a little bigger? The answers come out quite well. And I've had the opportunity to use this in many circumstances. Back in the good old days when I actually got to do the work instead of running the company, I remember many times I'd be in meetings where the government or the Air Force, whomever, was trying to come up with a size so they could get their program funded. And many times they tried to game this functional sizing. They tried to figure out, how do I trick the relative sizing? And it can't be tricked very well. Comes out beautifully. Again, if you've got SEER, this is included with the SEER package. I'm not sure how many people use it. If you don't, Tom Sandi's AHP program is wonderful, but people can estimate things relatively better than from scratch. So let's suppose, remember that little table I had? We had a relative size. Let's suppose we went into ice bags and we pulled out some seemingly relevant points. We know how many function points or whatever there were there, but we also could do a relative size. Is this a little bigger or a lot bigger than this other system from the database? And going through a process, it really works, and it's very powerful. And if you use a table like the one I showed you earlier, you can then justify your size or your size estimates really quickly. There are many viable ways to counter-estimate size. Standards are key. ISO standards are great. No ISO standards, there's standards for lines of code. Functional size is wonderful, whether it's counted or estimated, but I've seen people misuse that as well. I remember going into a program and they had this size that we had estimated or counted the size, and one of the contractors had a size and it was 2 or 3 times bigger. And we went in there to look at it and determined that they had invented their own functional sizing technique. They called it function points, but it was their company's version of function points. Did it work for them internally? I'm sure it did. Was it viable to compare to other contractors? Absolutely not. Did they do it so they look more productive than the other contractors? Probably. Don't dismiss lines of codes when they're counted appropriately, or estimated appropriately. Again, if you just ask a program how many lines of code, you're probably going to get a strange answer. By using processes of rigor, databases, counts of actuals, it can really work. One of my favorite old stories, many years ago, we were working in I guess I shouldn't tell you the company, but we were there supporting the U.S. government. And the contractor came in, a contract was going to be rebid, was going to be recompeted. And the contractor came in and had a size, it was over 1 million lines of code. I don't remember what it was, but it was over 1 million lines of code. And I looked at it and it just didn't look like 1 million lines of code to me. So I started asking questions. Was it all new? Was it pre-existing, et cetera, et cetera? The contractor got really angry and actually ejected me from the meeting. I was asked to leave the meeting where I was asking these questions. Well, of course, the government saw that all over. By the time we got back together again and the government got what they needed from the contractor, they found out that the contractor had included, I forget, 27% of all the lines were blank lines. Blank lines make things readable. Some other percentage were lines that wouldn't be delivered. Yeah, if you give garbage in, garbage out, but you can count lines of code appropriately, just like you can count or estimate function points appropriately. And keep seeking better and better approaches. The state of the practice is pretty good now, but the day we stop looking for how to get better is the day things I think will start going downhill a little bit. And I'm thrilled for conferences like this and the work that Nesma and others are doing to keep getting better and better. This is a great work. We are saving people billions of dollars. We are helping companies be successful. We're protecting the world. Software sizing and estimating is really important. And in the US, tomorrow is Thanksgiving Day. Thanksgiving Day is usually a 2-day holiday. Everybody eats too much, but the most important part of it is saying thanks. And as I watched this conference today, I said, boy, I haven't been in very many conferences this year, and I kind of missed them. So I want to say thank you to the organizers, to Eric and others that have organized this conference. I want to say thank you to all of you that have presented. And again, this is a great work. And I wish you all a great holiday season, whether you're buying toilet paper in line. I don't know if you have toilet paper issues in Europe. Toilet paper was at a premium for a while. But thank you, everyone.
Okay, thanks a lot, Dan. That it's always interesting to see what kind of news is reaching the US. But yeah, the toilet paper issue was indeed a big issue. That that is certainly the case. So thanks a lot for a great presentation, Dan. And before we